All right, let's talk about one of the most important stories in the history of neuroscience. But this one, it doesn't start in a lab with some big breakthrough. No, it starts with a single person, a man known for decades simply as H.M., a man who, quite literally, became trapped in time.
Seriously, just think about that for a second. What if you could never make a new memory? Imagine waking up every single day and it feels like the first day. You remember your childhood, your past, but the future? It's just a blank slate you can never, ever write on. Well, for a man named Henry Molaison, this wasn't some philosophical question. It was his actual life.
You see, Henry's entire life really pivots on this one single drastic event. For years, he'd been suffering from these awful, debilitating seizures. So, in 1953, at just 27 years old, he underwent a radical, totally experimental brain surgery. And get this, he lived for another 55 years, all the way to 2008. But you could argue that in a very real way, his life, as he knew it, ended that day.
Okay, so we really need to understand the context here. This wasn't some casual choice. Henry's epilepsy was what they call intractable. It was completely out of control and just ruining his life. The surgery was an absolute last resort. Technically, it was a bilateral medial temporal lobe resection, which is a mouthful, but it just means the doctors went in and removed a piece of brain tissue from deep inside both sides of his head.
But what happened next? Well, nobody could have seen it coming. The good news? The surgery actually worked in a way. It did reduce his seizures, but the cost was just devastating. He developed something called profound anterograde amnesia. What does that mean? It means he completely lost the ability to form new long-term memories. He was, as one scientific paper so perfectly put it, trapped in the moment for the rest of his life.
So you have this incredible personal tragedy, right? But out of that tragedy came this unbelievable opportunity for science. H.M.'s unique specific condition gave researchers a key they never had before, a way to start cracking the fundamental code of how memory actually works. And this is why his case became a scientific gold mine. His amnesia was what researchers called pure. Think about it. His ability to make new memories was completely obliterated, but his intelligence, his ability to speak, his perception of the world, all that was totally fine. For the very first time, scientists could study memory, and only memory, in complete isolation. It was like having a perfect window into one specific part of the brain.
So what was the first big piece of the puzzle they figured out? Well, it was that memory isn't just one big blob. It's got different systems. H.M. couldn't create new declarative memories, the what of your life, facts, things that happened. But, and this is the amazing part, his procedural memory, the how-to stuff like riding a bike or learning a new skill, that was totally fine.
And the classic experiment that proved this is just fantastic. They had him trace the shape of a star, but he could only see his hand in a mirror. It's way harder than it sounds, trust me. And what happened? Day after day, he got better, dramatically better. His hands were learning the task. But here's the kicker. Every single morning, when they showed him the setup, he insisted he had never, ever done it before.
This led them to another huge insight, another split in how memory works. He had zero recollection. He couldn't tell you when or where he'd seen something before. But he did have a sense of familiarity. If they showed him a picture from months ago, he'd say, "No, I don't remember this," but he might add, "But it feels familiar." This was proof that even our conscious memory has these different, separate layers.
Okay, so these discoveries about his behavior were absolutely game-changing. But every single one of them just pointed back to this one giant looming question. What exactly was physically different inside his brain?
And that question kicked off a detective story that would literally span more than 50 years. The central mystery they had to solve was what, down to the millimeter, had the surgeon actually removed back in 1953. So, the first clue came from the surgeon's own notes. Dr. Scoville wrote that he thought he'd taken out about an 8-centimeter piece of tissue from each side. I mean, that is a huge amount of brain.
But then, fast forward a few decades to the 1990s, we get the first ever MRI scans of H.M.'s brain, and they tell a totally different story. The damaged area, the lesion, was actually smaller, closer to 5.5 centimeters. Technology was starting to give us a much clearer picture, but it still wasn't the complete truth.
You see, even with these incredible imaging tools, there's a limit to what you can learn from a living brain. To get the final, precise, undeniable answers, science was just going to have to be patient.
And that waiting brings us to the final chapter of this incredible journey, the moment we finally got the clearest picture possible.
On December 2nd, 2008, Henry Molaison passed away. He was 82 years old. And that very same night, his brain, which he had so generously donated to science, began its last and most important journey. A journey that was about to unlock answers we'd been seeking for decades.
So what did they do? They used these incredibly powerful, ultra-high-resolution MRI scanners to look at his brain in a way that was never possible before. We're talking microscopic detail, down to 210 micrometers. It was a view no one had ever seen, and it finally showed the exact, precise boundaries of the surgical damage.
So the final truth, what was actually gone? The scans confirmed it. The surgery had taken out a cocktail of absolutely critical memory structures, the main on-ramp for memories, a huge chunk of the brain's emotional center, and the big one, the entire front half of the hippocampus. This was the smoking gun, the physical source of his amnesia.
But here's the thing. What wasn't removed was just as important. The key to understanding his few remaining abilities, like that weird sense of familiarity, was in the tissue that was spared. Turns out, a little tiny piece at the very back of his hippocampus and some of the tissue around it was still there, and scientists now think that those tiny surviving bits were just enough to give him that faint echo of a memory.
So, let's step back. After 55 years of constant study and this one final, incredibly detailed look inside his brain, what did H.M. actually teach us? What is his ultimate legacy? Well, he completely changed everything we thought we knew about memory. Seriously. Thanks to him, we now have this basic, fundamental model. Think of it like this. Information comes in from your senses. Then, this area, the medial temporal lobe, acts like a save button, encoding the memory. And once it's saved, it gets sent off to other parts of the brain for long-term storage. H.M.'s brain, by showing us what was missing, literally showed us where the save button is.
You know, for all the science, this whole story really comes back to Henry, the person. Despite everything, everyone who knew him said he was this gentle, kind man, always willing to participate in another test. When they'd ask him why he did it all, he had this simple mantra: whatever is beneficial. It's incredible, even without being able to remember his own contributions, he somehow knew he was part of something so much bigger.
So, in a tragic irony, H.M. lost the ability to create his own future memories. But in doing so, he gave neuroscience its own, a permanent, unforgettable memory of how our brains actually work. He gave all of us a clearer picture of ourselves. And it leaves you with this really profound thought, doesn't it? What is the true value of one single life when it comes to the future of all of us?